Hey there, and thought I'd start off with this cartoon, and I gotta admit it's maybe time to retire the attack of La Nina bit, but anyway, this does summarize kind of the past season, right, and what we're expecting. And so what I'm going to be talking about here for about 20-25 minutes, and hopefully there's some questions. Going to go a little bit a review of last year's winter, and then of course into the forecasts of what we're looking for the winter ahead. Here, this is I think the third time in a row I've been invited to this. I'm flattered and love doing this, but I feel like you're going to get sick of me, pretty soon. I'm surprised not already. And so one of the things I want to do is something a little bit different this time and talk about the skill that we have in our seasonal forecasts and kind of, in temperature and precipitation and season and so forth. So something a little different than before. And just very briefly, some of the short-term events. All right. Go ahead. So what I'm going to review of last year. What we do at the Climate Office each year is kind of the top 10 of the water year. As far as I'm concerned, the start of the year is October 1st. And so that's a big celebration in my household, the start of the water year, get all drunk and everything. Anyway, so starting off in October is really wet. I'm talking about October 2016, of course. And that is usually before the snow really starts flying, except for in the very highest elevations. And so perhaps people weren't too concerned about that. There were all sorts of precipitation records broken, and especially in eastern Washington, a lot of days of rain, which is kind of unusual. But by the time you get to November, usually, you're getting kind of a little bit more interested in the winter sports recreation, right? And this November of 2016 was pretty bad. It was in the warmest on record at various stations, and for the state as a whole. That map at the lower right shows where the darkest red, it was the record temperatures all time in those locations. The map at the upper right shows the flow anomalies, the anomalous circulation at 500 millibars, about 20,000 feet up in the atmosphere. If you aren't used to looking at 500 millibar maps, may God have mercy on your soul. I spend half my life, I think, looking at these and trying to figure out how they're going to work out. But essentially what there is around those lows, around that purple circle, there's more counterclockwise flow than usual. So winds from the south into Washington State, and around highs, clockwise flow relative to normal. And so you can see that was delivering warm air from the south, and no surprise why it was so warm. And so this, probably people are pretty depressed about this. But another thing that kind of contributed to that is that our prevailing winds, what I was showing there was kind of relative to normal, but our prevailing winds are off the ocean, and the ocean was considerably warmer than normal right along our coast last year. And so that kind of predisposed us toward a little warmer and wetter than normal because of just the extra heat picked up by the atmosphere from the ocean. So that was going on a year ago. Then we get into December, and it was a big switch. And again, this is a map of the sea surface temperatures relative to normal, but you can see at the equatorial Pacific, there are little kind of droppings of blue there. Very weak La Nina conditions, but for reasons not fully understand, it might just be a fluke, it had a disproportionate effect on the weather patterns and our weather here in the Pacific Northwest. And in particular, let's go. Yeah, here, again, looking at 500 millibars relative to normal, it's almost a mirror image of what happened in November. And I can't draw a better map than this in terms of delivering snow to the high terrain of the Pacific Northwest. With that, right, and this was last year, but I'm still enjoying it. Well, I'm not promising it for this year, mind. Okay, but with that, that higher heights than usual, higher pressure than normal off to the west, the kind of clockwise circulation around it, and the low to our northeast, that meant cold air coming out from northwestern Canada out over the ocean long enough to pick up a bit of moisture, but was still quite cold, and then delivered it into the northwest. And so many of you, I'm sure, recall just how snowy it was in December. And for the water year as a whole, it was cooler than normal. Not a great deal cooler than normal, but cooler than most winters we've had in the past decade or two. And definitely wetter than normal, especially on the west side of the Cascades. In fact, of all the 50 states relative to normal, Washington State was the coldest in the nation last winter. So, hey, we're number one, right? So, and of course that continued, it was really wet and cool into the spring, and so a really long-lasting season. Okay. Yeah, you've seen this before. Did La Nina have anything to do with it? Let's go to the next one. Again, going back to 500 millibars, this is more the winter as a whole, and the period I picked, December to March, for what it's worth, showing, again, a good setup for cold and wet conditions, and so obviously something that many of us enjoyed. All right. Brett showed this. Again, we're looking at a strong possibility of at least weak La Nina, maybe even into the moderate category. Certainly the chances of El Nino are essentially nil. So good news. In those kind of situations here, I kind of bounce around between what months I include and all that. But if you look at the temperature, this is a nationwide perspective, of course, on the left, and the precipitation on the right, with the kind of blue-green colors meaning below normal, and the yellow-red colors being above normal. You can see it's both, for the precipitation, the blue is above normal. It makes sense, you know, just the color scale, but that we tend to be a little bit on the cool, wet side during these kind of weak La Nina conditions like we're expecting this winter. And here, just to kind of give it a little bit more sort of concrete form, looking at Snoqualmie Pass and the total snowfall there, just in the inches, not the snow water equivalent, but just the inches of snow. The Snoqualmie Pass is a good one to look at the El Nino La Nina signal because it's so marginal in terms of its temperatures. With the colder temperatures, obviously, meaning snow, and the warmer ones, it gets plenty of rain. And you can see with the honest-to-God La Ninas, the moderate to strong ones that are colored in blue, it's systematically more snow there than with the El Ninos. The very last winter there, by some measures, it was a weak enough La Nina that it doesn't really qualify there, but that's kind of a matter of taste. But still, the idea is that, yeah, the NSAW phenomenon matters to our snow. It doesn't actually, we've had some La Nina winters with kind of just middle-of-the-road ones, and some El Ninos, especially in the past, that were okay, but El Nino's bad, La Nina's good. Oh, oops. I want to go, yeah, okay. One more, let's go to the next one. So I want to talk about the seasonal predictions and where they come from, the Climate Prediction Center, and what tools are used, in particular the models that are used, the statistical relationships and so forth. And in particular, what I want to focus on here for a couple of minutes is just how much skill we have in these forecasts. But before we get started, I want to share with you a comment that was made on the idea of, the merit of considering seasonal forecasts. And so the people in the back maybe can't read that, but this is again a comment on a news story a couple of years ago about some expectations for the seasonal weather in California. And I'm going to pick it up partway through, and it says, "This is wrong, pay no attention. It's just a bunch of snot-eating knuckle-draggers who continually predict the end of the world because of climate change. The glaciers are melting." So it kind of devolves into a complaint about global climate change rather than the merits of seasonal weather prediction. It ends up saying, "Occasionally by accident, these guys can correctly predict the weather tomorrow, but that's about it." So with that in mind, you're free to, I think some of the doors are still open and so forth, but if not, we'll press ahead. Yeah, and so here, it's kind of, for the nation as a whole and for all seasons rolled together, there's been some studies done to just see how good the Climate Prediction Center forecasts are. And essentially, it's temperature on the left, precipitation on the right. The redder the color into the browns, the better the forecast, and don't have to go into the exact metric here. And you can see that there's a lot more red on the temperature forecast than on the precipitation forecast. And it actually, in the western US, the Climate Prediction Center does better than other parts of the country. I took this a little further for some work that actually the Department of Ecology contracted with the Climate Office to do. And here, this is, math. Last talk of the afternoon, that's kind of dirty pool, and math is probably always dirty pool in terms of these kind of talks. But just suffice to say that what I did, I looked at different seasons just for Washington State, and I looked at the forecasts a half a month out for the next 3 months, and the forecasts for 3.5 months out for the 3-month group. And so the temperature on the left, precipitation on the right. The higher the number, the better. The perfect forecast would be 100. The exactly terrible forecast, if you got it completely wrong, the worst you can do is -50. Zero skill is 0. And this has to do with a system in which you are predicting below normal, near normal range, or above normal, so kind of a 3-tiered system. And the screaming message is, first of all, that temperature, again, for Washington State, we do a lot better than precipitation, and that fall is really hard to forecast. And this is something like 20 years worth of data, and so the statistics aren't great, but there's quite a few, separate, independent realizations that go into this. And I was kind of surprised how good we are at predicting the seasonal weather in summer. And this was a bit of a surprise, but winter into spring tends to be pretty good in summer, surprisingly good also. But precipitation, it's tough. And so you should always have that grain of salt ready to go or something. All right, so what are the, this is fine. What are the actual forecasts? Okay, this is, some of the text got lost. Yeah, okay. Anyway, on the left, these are temperature outlooks from the Climate Prediction Center. The map on the left, relative to normal, is for the November through January period coming up. And the map on the right is for the January through March period coming up, and I know there's an overlap there. But essentially, early in this upcoming winter, the Climate Prediction Center forecasts are just kind of equal chances of any of the categories, below normal, near normal, above normal. But as we get later into winter, that it's more likely will be on the cool side. And that is basically because the statistical relationships having to do with La Nina. Okay, precept. Oh, there's my text. Same thing here on the left is November through January. On the right, January through March. maybe into western Montana, maybe a little bit on the wet side early on. But again, it's later in the winter that we tend to see the effects of La Nina, and so that the official forecast is a little bit on the wet side. And so I would say that's pretty good news. There's increasingly a lot of resources that are being used to make these forecasts, and this is, this looks like kind of a mess, but what it is showing the individual climate models that now go into, that are an important part of making these forecasts. And so on the bottom two rows there are individual models, some from Canada, but most from the US. In the upper left is the kind of, the average of those, and just kind of concentrate on that. And the period here is December through February that I picked up for this. And those models as a whole, some are showing it cooler, the blue's cooler than normal, the one on the kind of middle far right. Others are showing warmer than normal. And so as a group, they're showing near normal. But the Climate Prediction Center, again, because of the past relationships with La Nina are kind of shading that toward the cool side. And so, but this kind of gives you an idea of the uncertainty in this whole game here. In terms of precipitation, it's the same sort of thing. Some are showing wetter than normal, others are drier than normal. Most of them are showing wetter than normal, but here I actually direct your attention to the upper right plot there, and this shows they're trying to take into account of where the model's systematic biases. Some of them always tend to be kind of wet or always kind of dry, and just trying to take that into account. And the idea there is that probably on the wet side, but we're not really that certain, of course. All right, one more. Back to the sea surface temperatures. This is something near and dear to my heart. A lot of my research has to do with how the climate impacts the marine ecosystem of the North Pacific. Here's a recent sea surface temperature anomaly map showing it's still a little bit on the warm side off our coast, but not as warm as a year ago. And there you can see in the tropical Pacific some blobs of cooler water showing this La Nina conditions that seem to be brewing out there. If you actually look at the relationship between our sea surface temperatures in degrees C on the kind of horizontal axis at the bottom there versus the temperatures for the winter, and these are the temperatures, the SSTs in October versus the temperatures in Washington State for the winter following, there's not an incredibly tight relationship, but when the water is cool out there, we haven't had really warm winters, and when the water is really warm out there, we haven't had really cold winters. Last winter was actually kind of an outlier, given how warm the water was. It was kind of unusual that we got as cold as it was, and it was just because we were in such a favorable kind of circulation pattern. Anyway, we're now, the waters are still a little bit on the warm side, but not as warm as the last few years, and so that's good news in terms of our temperatures. Whoops. The thing to kind of keep in mind is that there's a little thing called global warming that's happening, and these dots here show what the temperature trends are in different seasons, both in terms of the max temperatures each day and the minimum temperatures each day. And yeah, the climate is warming, and so we're facing that rising baseline of temperatures. And so another way to look at that, there we go, is here I've taken the climate division that is basically the west slopes of the Cascades back to 1895, and the temperatures, this is December through March for what it's worth, for each of those years, back and forth. And there's a lot of year-to-year variability, but obviously a warming trend. And the years that I think are comparable to this one that we're facing are highlighted there, 05, 06, 08, 09. let's see, 11, 12, and last year is kind of, has some similarities to this one where it's a kind of a recent weak La Nina conditions. And so you can see that they're below that trend line, but the warming climate with the kind of cooling of La Nina kind of cancels out, so something close to normal relative to a long-term average. All right. So again, looking at those last, those 4 analog winters, 05, 06 in the upper left, 08, 09 upper right, 11, 12, and then 16, 17. 3 out of 4 were a little bit on the cool side. You know, 3 out of 4 dentists recommend you chew sugarless gum, right? So the same thing for the temperatures here. One of them, you know, not so much. It was near normal, 05, 06. In terms of precipitation, kind of a mixed bag. Of course, it was wet across the entire West this last winter. 05, 06, pretty wet too, but some of the other ones kind of middle of the road. So you know, again, to give you an idea of the variability we have here. All right, so in just the last couple of minutes, I want to talk just a little bit about more kind of event scale stuff, and not even necessarily things related to winter sports in the mountains and avalanches and so forth. And in particular, some of the work our office is trying to do coastal flood events. I'm not actually going to talk about those, but trying to predict those, or cold air outbreaks, air pollution events. That's actually a big deal around here. So, floods. Here on the Snoqualmie River, and not all rivers kind of react the same way. What I've done is the same sort of color coding with the El Nino winters in red and the La Nina winters in blue. And these are the serious El Ninos, the big ones, and the moderate to strong La Ninas. And what was the peak flood, peak stream flow each year. And you can see, at least on this river basin, the La Ninas tend to have higher floods than in the El Nino years, but there's a lot of scatter there. Again, last year we didn't actually have a really big flood on the Snoqualmie. This weekend we've done better than that. We had some, kind of minor to, I don't know what the category was, but there was some minor flooding on some of the area rivers. So that is something that, depending, not all rivers react the same way, but a lot of them greater odds for some flooding, but not necessarily the really devastating floods. All right, next one. Lowland snow. If you can't get out of your driveway, you're not getting up into the mountains, right? And this is something most people are familiar with, that we're not getting as much snow as we used to around here, and there's, especially in the lowlands where we're temperature limited, there El Nino is basically, that's a disaster if you like snow, but no guarantees. But we have had some big winters during La Nina, and they are just to illustrate the kind of time series. And this is again an illustration. This is climate change in action, folks. And the total snowfall at SeaTac. Just even the big years aren't like the big years in the past decades. But 08, 09 is one of my analog years, and many of you might remember what it was like right before Christmas for a couple of weeks, in which, the place was basically shut down. All excuses were valid. That was great. Irish coffee at 9 a.m., I couldn't get in, right? So, anyway. All right, so one piece of good news, though, especially in the climate change business, it's always doom and gloom. Because temperatures are warming up, people aren't burning as much wood. They're burning with better stoves, and that is having a demonstrable impact on our air quality. Here, just the mean particulate concentrations in Kent, Washington, back a couple of decades. Steady decline. Again, I've done my little color coding there. It doesn't seem to matter that much whether it's El Nino or La Nina. Every winter we have some at least minor pollution episodes, but that's of real public health success story. And the proportions there, if you look at the scale there, the air is, the particulate concentrations are less than half what they used to be not that long ago. So maybe we should pat ourselves on the back for that. Okay, so just a couple more slides about, the winter ahead. One thing that I kind of mentioned, but don't get your hopes up too early. The effects of La Nina tend to be after the first of the year, just kind of like in 2016-17 when the November was so warm and all that. We don't really see, sometimes there's an exception, but we don't tend to see a really good buildup of snowpack early in the season necessarily. And just looking at what the models are suggesting the next couple of weeks, it's not looking so good. So, clean out the garage, or do whatever you need to do, but don't panic, because chances are the effects will kick in more after the first of the year. No guarantees, but that's when they tend to happen. All right, and so and here's just kind of a sample year again. 05, 06. One of my analogs is what I have at the top is daily temperatures compared to the records in the normal from October 1st through the end of March for that winter, and the accumulated precipitation, the lower graph. This is for Stampede Pass. And just to kind of illustrate that in most of these kind of winters, we'll have a few at least moderate cold air outbreaks. These tended not to have much precipitation with them, but when there was a period of warmer weather in the kind of near the first of the year into the first half of January, it wasn't too wet for much of it. And so one thing we tend to see in La Ninas is fewer of those Pineapple Express, just southwesterly flow, drenching rain sort of things. And so that's the sort of stuff that really does, well, it stabilizes the snowpack, but it does, obviously conditions aren't so good. And so we tend to see fewer of those during the kind of winter that we're having coming up. All right. So to summarize, floods, we're going to have some major floods. Well, we have them every winter. Don't know whether they're going to have the most severe ones. Windstorms, it's even harder to say. But we're kind of due. It's been a while since we've had, but again, that's something maybe a few days ahead of time you can anticipate. Cold air outbreaks, we just don't see them as intense as we used to. Because of La Nina, they're a little bit more likely. Whether they're going to be, temperatures down well below, like into the low teens in the lowlands and, below zero in the mountains, hard to say. But a few events are pretty likely. Fog air pollution's getting better. And then the last thing, the kind of end of season snowpack. Can't expect something as good as last year. I can almost guarantee better than 14, 15, which isn't saying that much. And so, at least near normal and probably a little bit on the high side. So this, I think, summarizes the forecast pretty well. And just there, be thankful you're not in the Dakotas, right? Right? Yeah. I should have just put this up and stood down, right. And so with that, I'll just kind of take some questions. And if you want to get a hold of the Climate Office, there's the information here. You Google it, you can find it. If you're, we're happy to give you some data or talk to you about this stuff. If it's an unreasonable request, we'll tell you to buzz off, right? But we're here to, serve the public. And so with that, thanks.
So we have a few minutes if anyone has any questions for Nick.
In one of your graphics, you had correct by chance. What does that mean?
Oh, yeah, that's right. Yeah, there it was just the kind of skill score that is used that for these kind of 3-tier forecasts. And so if you're saying the temperature's either going to be below normal in the near normal range or above normal range, you're going to be right a third of the time if you're just guessing or pulling it out of some orifice or something like that. And so in the actual way that that's tabulated, you kind of see how much better you are than just 1 out of 3 chance. If you're getting it right just 1 out of 3 times, then you're not doing anything better than a pure guess. So yeah, I kind of glossed over that, and yeah, sorry about that. Any other?
Any other questions?
Right here.
We need to get on the mic.
Thanks a lot, Nick. It's great to have that kind of expertise here in the Northwest. I just want to give you a variation on a question I asked earlier today, and that's relative to the new GOES-R satellite.
Okay.
Are you excited about the new capabilities and higher resolution?
Yeah, and certainly that's going to help us in the kind of day-to-day forecasts and so forth. These are seasonal forecasts. Yeah, it's not going to help so much for what's January going to be like, but certainly the increased capabilities, our observational capabilities, and the models are getting better and so forth, and people joke about it, and I'm used to it and all that sort of thing. But your weather forecasts are a lot better than they used to be. And we're never caught with egg on our shorts. Oh, well, you know what I mean. With our pants down. That's probably a better metaphor. In that we might not get the storm exactly right and so forth, but we're never completely surprised when something happens out of the blue. And, obviously we don't get the precipitation amounts and the timing exactly right and that sort of thing. But there are not the huge surprises that used to occur not that long ago.
Cool. Time for one more question, if anyone has one. Yeah. Come on up, Mark.
Oh, I was afraid of that.
Nick, I was wondering if you have any evidence to suggest that the easterly flow situations, which provide us with a lot of the snowfall that passes, if there's a decrease in the frequency or intensity of easterly flow situations with global warming, with climate change. Do you have any?
I have to admit, I don't know, and that's and I feel like I should. And so my apologies there, but that would be something that'd be reasonably straightforward to check. And you're talking about on the event scale, how many days with easterly winds and so forth. My hunch is that maybe a little bit fewer than well, yeah, I don't really know. I'd have to do that. Typically on the large scale, what La Niñas do is bring us more air out of the Gulf of Alaska rather than straight off of the Pacific. But how that equates at low levels to just Snoqualmie Pass, Stevens Pass, and so forth is a good question.
2000 or NSAW 2018 is exactly a year away. So you can plan for that.
Yeah, so I guess I got my marching orders or something.
Yeah. All right, well, thank you, Nick.
Yeah, thank you.
Well, that concludes our NSAW 2017s. But before you get up out of your seat, I'd like to say a few things. First off, I'd like to start by thanking all the speakers. It's pretty invigorating to see all the research that's happening and the knowledge that gets shared in this room at this event annually. Next, I'd like to thank our title sponsor, OR, and our other title sponsor, the American Avalanche Association. Both OR makes amazing products, and we're extremely glad to have their support at this event and at the Avalanche Center in general. And if you're a professional in the industry, I'd encourage you to join the American Avalanche Association. I'd also like to thank all of our main sponsors and supporting sponsors to help make this event affordable to all of you. And next, I'd like to thank all the staff at the Avalanche Center, along with the forecasters that helped put this event together. We also have 11 volunteers that help make this event work, and we wouldn't be able to execute it without you all. So thank you all. And then lastly, from a thank you standpoint, I'd like to thank all of you for spending this glorious day inside, learning and prepping and engaging with the upcoming season and engaging with the community at large. I think it's really commendable, and it's really a cool thing to see all of you come out today. And then a reminder, I'd like to remind you all that the Northwest Avalanche Center is your Avalanche Center. Our job of equipping and empowering you all to get out and recreate in the winter is something that we're all proud to be a part of. But I want you all to remember that this Avalanche Center is your center. And so we'd like to know how we're doing. We'd love to see more of you out volunteering. And just a friendly reminder, join, participate, become a member of this center, stay engaged. And then I'm gonna poke you. That weather station survey that we sent out that's in your inbox right now, we would love to have your input. We'll have that survey up for 2 to 3 weeks. So please tell us what you think about our weather stations. Regarding today and what you've learned, the videos will be up online somewhere around Tuesday this week. We have a Northwest Avalanche Center YouTube channel, so please check that out. Follow the channel. All the videos, all the presentations today will be up this week. And then finally, I've learned a lot today, but I've also learned several new ways to engage in the community. Whether that's collecting algae, tracking wolverines, and participating in various ski tracking programs on several research projects. So I would encourage all of you to get involved with those various projects, along with getting involved with the Avalanche Center.